Then what we need to know is the different addressing levels in data communication networks. And then at the, for instance, at the lower level, we usually use link level addressing, where in that level we have typically the MAC addresses, that is the physical address of the Ethernet nodes in a local area network. Above the link level, we have other addressing that correspond to the network addressing level. For instance, in the TCP/IP networks, the internet address. In the case of IPv4, the internet address is a number of 4 octets, that is 32 bits. In the case of the MAC address, the MAC addresses have 6 octets, that is 48 bits. And then we could talk about, for instance, the addressing level at the transport protocol level, and at that in that layer, the transport protocol address is associated with something called the port number that is used to multiplex the different traffic flow or traffic packets exchanged between application processes. And overall, at the application level, we have different application-specific addressing. For instance, the FQDN, the full qualified domain name, that is the address the address in the that is used in the DNS, in the domain name system, or for instance the email addresses in order to exchange mails. The email addresses in fact use within the FQDN, the full qualified domain name from DNS, or we could use, for instance, the HTTP, the typical addresses that we use in web, into the web sites, and that addressing is called URL, unique the unique resource locator, or the unique resource indicator. And in that way, we could see that there are different levels of addressing depending on the layer and the functions that are performed in that layer. We were talking about OSI reference model, that is Open System Interconnection Reference Model, but in fact we use in Internet another architecture based in another model. That architecture is called TCPIP architecture, or TCPIP network, and it is based in another model called DARPA model or DoD model that comes from Department of Defense, and that comes from Defense Advanced Research Project Agency. And in this architecture, the model is a model that defines 4 layers called the network or link layer, Internetwork layer, transmission layer, and application layer. And The architecture defines at each layer different protocols, typically the Internet Protocol, the IP, the TCP, the Transmission Control Protocol, the UDP, the User Datagram Protocol, and other protocols, for instance, at the application level, the DNS, the Domain Name System, the Telnet, the FTP, the File Transfer Protocol, the HTTP, the Hypertext Transfer Protocol, and other protocols defined at the different levels, particularly at the application level. Those typically are the most used protocols, that is Internet Protocol at the network layer, ARP, Address Resolution Protocol, used in fact at the layer 2 at the network or data link layer, and the ICMP, the Internet Control Message Protocol, that is used at the same layer than IP, is a protocol that is used with IP at the third layer. TCP, Transmission Control Protocol, User Datagram Protocol, both at the transmission layer. DNS, Domain Name System, HTTP, Hypertext Transport Protocol, SMTP, Simple Message Transfer Protocol, in order to send mail messages, or IMAP, Internet Message Access Control Access Protocol, used to retrieve mail messages from a mailbox account. And this is a typical network topology. In TCP/IP networks, we call about host when we talk about the end systems. And in the intermediate systems could be switches, hub switches, or typically routers. The routers are the entities, the intermediate systems that work at the internet level. Then in the application layer, the communication is end-to-end, and is a communication between processes, between application processes. The transport layer is the layer at which the communication is end-to-end, but in fact is not a communication process to process, but a communication host to host. Remember that within a host, within an end system, we could have several processes. Then the difference between those layers is the transport guarantee the communication between hosts, that is, end systems. And the application layer is the layer at which the communication process, the communication is based in a process-to-process communication mechanism. Typically here we have the different messages, protocol messages at different layers. Typically the data of the application layer is encapsulated within the UDP datagram, the user datagram protocol. After that, the UDP message is encapsulated within the IP datagram, and finally the IP datagram is encapsulated within the payload of the frame, and that frame is the frame that travels across the link to reach the neighbor. And when we talk about TCP/IP networks and about the model used by the TCP/IP architecture, we could compare the DARPA model or the TCP/IP model with the OSI model, and in that way we could understand which are the functions implemented at each layer. For instance, the functions implemented at the network layer or link layer in the DARPA model are the same as ISO defined in the OSI reference model at the physical and data link layer. The functions implemented at in the Internetwork layer are the same as the functions implemented or defined at the network layer in the OSI reference model. Transmission, for instance, the functions implemented at the transmission layer are equivalent to the functions proposed at the transport layer of the OSI reference model. And finally, the functions implemented at the application layer in the DARPA model or TCP/IP model are equivalent to the application, the presentation, and the session layer of the OSI reference model. Talk about the Internetworking devices, that is the intermediate systems that typically are used within the networks. We will talk about, we will refer to those Internetworking devices as repeaters and hubs, bridges and LAN switches, routers, gateways, and proxies. Then, depending on the layer at which operate each Internetworking device, we'll talk about different kinds of intermediate systems. In the case of repeaters and hubs, the repeaters and hubs perform functions only at the physical layer, at the lowest layer of the OSI reference model. And typically, a repeater or hub, the difference between a repeater and a hub is the repeater has only two interfaces, but the hub could be more than two interfaces and perform a repeating function between any pair of interfaces with of the different ports that has that hub. And then one of the functions of the hub is to receive a signal, a digital signal, decode the signal, and retransmit the information, coding a new digital signal over the other link. In that way, we could avoid the retransmission of the noise of one link to the other. That is, the repeater is not an amplifier, is a repeater. That is, the repeater decodes the digital signal in one interface, in one port, retrieve the information, and retransmit that information, coding another digital signal. The other function of the repeater is to, in fact, regenerate the signal in order to send a new digital signal with a better power over another interface. One other typical functionality of the repeater is to use different kinds of physical medium. For instance, the repeater could receive a bit stream across media, for instance, across use UTP media, an unshielded twisted pair cable, decode the signal and recode the information into another signal that travels across, for instance, fiber cable. In the case of the bridges and LAN switches, the bridges and LAN switches are intermediate systems or are internetworking devices that perform functionalities at the two lower layers, that is at the physical layer and the data link layer. In that way, the bridge, the difference between a bridge and the LAN switch is the bridge is an old device used during the 70s and 80s years. But in fact, the bridging, the functionality is used within the LAN switches. LAN switch, in fact, is some kind of multi-port bridge. And perhaps the difference is that the old bridges work across one interfaces. Today, LAN switches work across only LAN switches. That is, for instance, Ethernet switches. And the switch, in fact, receive the digital signal, decode the signal, but receive and store the old frame, that is the PDU of layer 2, and after that retransmit the frame across the other interface, the other port. This is an important difference compared with the repeater or hub, because in the case of the repeater doesn't store the frame, and there is only a very short delay from the arrival of a bit in that interface and the transmission of that bit in the other interface. That's why, for instance, the repeaters and hub couldn't adapt different rates, different speeds of transmission. If we receive a bit stream at, for instance, 100 megabits per second, we need to retransmit the bit stream across this other interface at the same speed. In the case of bridge or typically a LAN switch, we are able to adapt different speeds. For instance, we could receive a frame across this link at 100 megabits per second. We store the frame here, and then we forward the message, the frame, across the other interface at a different speed, for instance, at 1 gigabit per second. And in that way, the bridging or LAN switching permit that we can adapt different speeds. And in the case of the routers work at the 3 lower layers of the model. And the router, the difference with the switches is in the case of the switches, the switches are only used to local communication between systems, but the router, in fact, is the device that permit to communicate systems from one site in the world and another site very far away in another place, in another site, and in order to bring that solution, the router have to route the messages based on the destination address of the message of the packet and choosing the best route to reach the destination. Finally, the gateways and proxies are internetworking devices that work at the highest layer, that is the application layer. And that kind of internetworking devices are used typically to adapt different network architectures or to implement some kind of security functions, for instance, to control the flow of information between users, for instance, in a private network that need to access information across a public network like the Internet network.